Okay, we're going to look at page 67. And we're going to look at the properties of log, actually applying them from our previous handout. So if we're going to apply them from our previous handout, let's try and remember what they all are. So the first property was the property, the product rule. So if we have log base b of mn, remember that that's log base b of m plus log base b of n, and it goes back and forth. So if we want to write two logs being added as a single log, we write the single log with their product. Then we had the quotient property, which said log base b of m divided by n can be rewritten as log base b of m minus log base b of n. So again, if you have two logs being subtracted and you want to write them as a single logarithm, you would do that. And then we also had the power rule, which said log base b of m to some power can be rewritten as p log base b of m. So again, if you have a coefficient in the front of a log, you can always rewrite it by taking it to the back. So I'm going to call these properties 1, 2, and 3 as we refer to them. So the first problem we have going on here, log of 4x minus 3 minus log of x. Now we don't see a base, so this is going to be a common log. And so they both don't have a base, so they're both common log base 10. And so we want to rewrite all of our logarithms as a single log. So we have subtraction of two logs. So by 2 above, we can rewrite this as log. We can write the base 10, but we don't have to. 4x minus 3 over x. And that's it. All right, let's look at question number 2. So right away, I notice that I have a log with a base of 2 and then another log with a base of 2. And so it makes me want to use the product rule property. But the product rule property doesn't work if there's a number in the front of a log. So we actually need to use that third property first and take that 4 and put it as the exponent on the y. So that would be log base 2 of z plus log base 2 of y to the 4th power. So now we have log base 2 of something plus log base 2 of something else. And so we're going to write that as a single log, log base 2, and z will multiply. We'll write it as a product, or zy to the 4th. Sometimes I'll put parentheses around that so that way I know my whole argument there is inside. And that would be my final answer. All right, let's skip down to number 3. Now we have 3 logarithms. Now they say ln, but remember that's just natural log. Remember natural log of x is just a log with the base of e. So all of these have that going on. Now before I can use my properties of log, for the adding and the subtracting, I'm going to want to get rid of that coefficient in the front. So that 3 will have to go and be an exponent, and that was by that power rule. So by 3, we can rewrite this as natural log of x to the 3rd power plus natural log of x minus 2 minus natural log of 5. And we can do this in baby steps here. These 2 logs are being added. So by our product rule, that was our first property, that will be natural log of x to the 3rd times x minus 2. And we still have minus natural log of 5. Now by our quotient rule, which we label that as 2 above, we can rewrite this as natural log of x to the 3rd times x minus 2 all over the 5. Again, we have a single logarithm, and it's of all of that stuff. Now, one thing that you might notice just from the beginning is that anytime you have a negative, or a subtraction actually, that's like having a negative exponent. And what happens when you have negative exponents? Well, they normally end up doing the reciprocal or living on the bottom, and you're going to see that happening anytime you have a negative in the front. That property, that quotient property, can really be seen as taking that argument and moving it down to the bottom, similar to negative exponents. All right, number 4. Ooh, that one looks kind of complicated. We have brackets in there, and we have actually 4 logs being there. So there's a few different things you can do. When I see the big brackets, I'm trying to think about, well, why are those there? Okay, well, there's a 2 in the front. Well, maybe we could distribute it. That would make things simpler. So we have 2 things inside that bracket. So if we multiply that, it'll be 2 times natural log of x minus 2 times natural log of x squared. And we have plus 2/3 natural log. I'm not going to do anything with these just yet. And natural log of z. Now they all are natural logs, so they all have the same base, which is e. And we can use our properties, but first, our quotient rule and our product rule, but first I really want to use the power rule. So all we did in the first step was distribute a 2, which is fine. But now we're going to take the 2, bring that back, take that 2, bring that back, take the 2/3, bring that back. So that way I have all of my natural logs having a coefficient of 1. So this will be natural log of x squared, and all of these we're using that power rule property. This will be natural log, well, if you have x squared squared, that becomes x to the 4th. Over here, we're going to have natural log of z to the, well, if you have a power already, this is, let's see, we'll switch this up a little bit. This is z to the 9th already, but then that has a 2/3 power on it. So this power to a power, if we remember our exponent rules, we multiply. So when you multiply, this is like 9 over 1. The 9 and the 3 can reduce here, so that's 3, 1, and so we end up getting z to the 6th power. So we'll have plus natural log of z to the 6th minus natural log of z. Now we have the 4 logs, we can individually use each property, but if we kind of think about what would happen, we have minus here and minus here. We can kind of put those 2 guys together or know that they're going to be divided by, so we can just stick them in the denominator. But we can do it in baby steps. So right away, these first 2, that's subtraction if we just go from left to right. So by the number 2, the quotient rule, we can say this is natural log of x squared over x to the 4th, and then we could just leave the other guys for a minute if you'd like. Then these could combine together, and so by 1, the product rule, that can turn into a single log of them multiplied together, so it would be x squared times the z to the 6th, and then that's over x to the 4th. Minus still just that natural log of z. So then by the quotient rule, which was our second guy, this would become natural log. When you're subtracting, this will become divided by z. So it will be x squared times z to the 6th over x to the 4th times z. So now this would be almost done, but we could simplify on the inside there. So if you look at just the way the exponents are, and we have the 2 of the same bases, those are all x's. So the 2x on top will reduce and make us have just 2 x's in the bottom. And then that has a base of z, so I'll have z to the 6th over z. That leaves 5 z's on the top. So final answer, we have natural log of z to the 5th over x squared. So kind of look at it, this big crazy expression with lots of sums and differences and powers simplifies down to just natural log of z to the 5th over x squared.